Buddy, yeah, this afternoon I want to solve this problem. Okay, yeah, good afternoon, everyone. You are all welcome to this afternoon class. I'll be very brief. I want to look at a second order differential equation, which is homogeneous differential equation. That is the type. I'm going to solve this. We'll use the operator and the other numerical way to solve this second order differential equation. Is that clear? So please, I want you to like, comment, and share. I will be very grateful. Thank you. Okay, so let's look at it together. Let us look at it together. We write solution. Solution. Let me use this. Okay. Okay. Write solution. This is d squared y all over the x squared minus 4dy all over the x plus 13y equals to 0. So if I may ask, what is the solution to this second order differential equation? You know, in one of my videos, I try to define differential equations and how to obtain second order differential equation like this. Is that clear? So if you have been following me, you don't need a prophet to tell you the solution of this second order differential equation is nothing but we have to let, since the differential equation is the independent variable is x. So we now write let y be equals to a exponential mx. I'm just using numerical method approach to solve. Then after that, I will use the operators. I told you I'm going to use two methods. Is that clear? People are confused with the d operator. Okay. So now here you let y equals to a exponential mx. So it means the differential equation here, the dependent and independent variables are x and y. So that is why you are letting y equals to. But supposing here is, let me say t, and here is x. Here you are supposed to use let t equals to exponential mx. So take note. But supposing here the independent variable is t and y all over dt. It means y equals to a exponential mx, mt, sorry. That is how you are supposed to. So let this be equals to this. So it means this is the solution of this second order differential equation. Amen. So let's do it together. What next is for us to differentiate this function with respect to x. Is that clear? And we are not just going to differentiate it once, we will differentiate it twice. Why? Because the differential equation is a second order. Do you agree with me? Are you following? Thank you. Okay, so let's look at it together. So it means we have to differentiate this function twice. So it means our dy all over dx going to give us a, if you differentiate exponential mx, you have a m exponential mx. Then since it is a second order, So we are going to differentiate this to have d square all over x square. This is equals to, if you differentiate, if you differentiate this, you are going to have a m square exponential mx. Do you agree with me? So at this point, we have to substitute this and this into this second order differential equation. Mind you, instead of this, we write this. Instead of this, we write this. And instead of y here, we write this. Is that clear? So what we need to do here is, okay, excuse me. Yeah, I'm right. The question is complete. So what we need to do here is for us to substitute this here. So instead of this, we write a m squared exponential mx. So a m squared exponential mx, amen. What we have here, minus 4 times dy over dx. Look at it here, is am exponential what? Am exponential mx. Then what do you have here? Plus 13, right? Plus 13. What is your y? You said let y be equals to a exponential mx equals to what? 0. Do you agree with me up to this point? Any question, viewers? If you have any question, drop it in the comment section. So can you see now? Amen. Are you following? Victor Billions, how are you? Where are you watching from? Okay, yeah. So if you agree with me, if you can see what I am saying at this point, or I should give you some time to ask a question. Any question, please? Do you have any question? Do you have any question? No question? Okay. So let's look at it together. So look at this equation. Look at it. We have a m squared exponential mx minus 4am exponential mx plus 13a exponential mx equals to 0. So just ask yourself what is common here. Look at the left hand side. If, as you can see now, the left hand side, something is common. Can somebody tell us? Yeah, I can see that a exponential mx is common, true or false? So we have to factor it out in order for us to obtain our auxiliary equation. Is that clear? So let's factor it out. A exponential mx is common, so we factor it out. So it means a exponential mx, open bracket, it means here m squared will be inside the brackets. Then what we have here, minus 4m will be inside the brackets. Then what is here, plus 13 will be inside this bracket. Close the bracket. Then equals to 0. Amen? Do you agree with me? Are you following? Yeah. Any question? Do you have any question? Yes or no? Yeah. So it means at this point, if this function a exponential mx is not equal to 0, and this will be equal to 0. So it means if a exponential mx not equals to 0, it means this bracket will be equal to 0. M squared minus 4m plus 13 equals to 0. And this is called the auxiliary equation. This is the auxiliary equation. Auxiliary equation. Amen. So this is our auxiliary equation. Yeah. Those of you that are not familiar with mathematics and you are familiar with quadratic equation, you want to call this a quadratic equation. Yes, it's a quadratic equation, but as long as a differential equation is concerned, this quadratic equation is obtained from this second order differential equation. So we cannot refer it as what? A quadratic equation. Rather, it is known as what? Auxiliary equation. Please take note. So whenever you hear somebody calling this an auxiliary equation, mind you that it was a product of a differential equation. That is why it is called what? An auxiliary equation. Take note. Is that clear? Any questions so far at this point? So it means we are going to have roots. You know, just like when you solve your quadratic equation, you obtain your x1, x2, two of us. Likewise, we are going to obtain m1 and m2 from this auxiliary equation. Do you agree with me? Any question? Love you guys. Please share and like. I'll be very grateful. Don't just watch. Okay, and listen. Yeah. So far, so good. So we can proceed further to look at it. I mentioned it earlier that I'm going to use two methods to solve this. Now I'm using numerical method. Then after the numerical method, I'm going to use the operators. Is that clear? So now let's look at it together. Amen. How can we solve this? You don't need a prophet to tell you. Yeah. Do you need a prophet to tell you? We can use either formula method or factorization method. So if we use formula methods, it means since we are talking about n, so our n is equals to what? Minus b plus or minus square root of b squared minus 4ac all over 2a, two of us. So if we are to use formula method, it means our a is equals to 1, b equals to minus 4, and c equals to 13, two of us. So our n will now be equals to minus, open bracket, minus 4 plus or minus square root of minus 4 all in square minus minus 4 times 1 times 13 all over 2 times 1, because your a is 1. True or false? Do you agree with me? Hope you are following. Okay, so if you agree with me, it means our n, amen, will now be equals to minus times minus plus, the here will be plus or minus, then square root of this is going to give us plus 16, because it's just like you have minus 4 all in square. This is the same thing as minus 4 times minus 4, minus times minus, plus 4 times 4, plus 16. Do you agree with me? Okay, so here is then minus 4 times 1, minus 4 times 13, 12, carry 1, yes, is 52, right? Minus 52, true or false? Because 13 times 4, 12, carry 1, 4 plus 1, 5. Any question or no question? Do you agree with me? Do you agree with me? So, as you can see, 16 minus 52, I will just do it this way. 52 minus 52 minus 16, 12. Borrow one from this 12. 12 is 6. Then here is what? Here is what? 4. 4 minus 1 is 3. So we are going to have minus 36. Am I right? So our m is equals to 4 plus or minus square root of minus 36 all over 2. Yeah. So as you can see, we cannot have the square root of minus 36. True of us. Mathematical error if you press calculator, your calculator, true of us. So for now, what we need to do, I will now refer you to what is called complex number. What is complex analysis, true of us. In complex analysis, note that your I is always equals to square root of minus 1. Do you agree with me? So for that purpose, then let us apply SOD here. For that purpose, let's apply SOD here. So if you can see what I am saying, square root of minus 36. This is the same thing as square root of minus 1 times plus 36. Then this implies that my square root of minus 1 times square root of 36. Do you agree with me? Then square root of 36 is what? 6. So square root of minus 1 times square root of 36 we're going to give us 6. True of us. Do you agree with me? Are you following? Please. I'm breaking it down because of you so that you will answer it. Thank you for each. I really appreciate. Please, I would love you to share this video. You are watching from NY. I'm very grateful for being here, watching what I'm teaching. Help me share, like, and comment. Okay, so you agree with me, right? So it means I is minus what? Square root of minus 1. So it means this will now be equals to I times 6, which is equals to 6I. Do you agree with me? So this implies that, if you agree with me, it implies that here we are going to have, I want to clean this. So this implies that our m is equals to 4 plus or minus, because of this gives us what? It means, let me just say square root of minus 36 is equals to this. So 6I all over 2. So this is equals to 4 over 2 plus or minus 6I all over 2. Amen? Do you agree with me? I hope you are following. So this implies that, I can clean this, right? This implies that our m will now be equals to 4 divided 2 is 2, then plus or minus 6 divided 2, 3I. Can you see now? Then here, when we say plus or minus means minus either plus, first plus, comma, minus. Do you agree with me? So it means because of that, because of plus or minus, we are going to have our m1 equals to, if it is plus, we are going to have 2 plus 3I. Then our m2 will now be equals to 2 minus 3i. Do you agree with me? So now, we now go back to our general form of differential equation. The general form of differential equation is y equals to, since the roots are not the same, true or false, but although these roots are complex roots, is that clear? Because of I, they are complex roots. But let us first consider the general form of these distinct roots. Is that clear? So here will now be equals to either C1 exponential m1x plus C2 exponential m2x. Sorry. So y, that is our general solution, now will be equals to C1 exponential m1 is 2 plus 3i, all in bracket x, then plus C2 exponential m2 is 2 minus 3i, all in bracket x. Yeah. This is the general solution, but for the fact that the roots are complex roots, it will not make sense. There will be no sense of belonging if we leave the general solution in this form. Why? Because the roots are what? Complex number. Is that clear? Before I proceed, I want you to ask question. If you have any question, drop it in the comment section, and I'll be grateful, be glad to respond to your question. Any question? I'm waiting. Do you have any question? No question? Okay. Okay, let's proceed. So now, if you can see what I am saying here, I will explain this explicitly. Look at it. Can I clean this up? Yeah. Let me clean this up. Okay. Yeah, I know that one can start there, but as a mathematician, you have to still move further, and I've told you the reason why. You have to move further, you cannot just stop there. Why? Because they have complex roots, so you cannot just stop it like this as a mathematician. Okay, so as you can see now, if, assuming we have exponential, let me say a plus ib all in bracket x. I want to do something. That is why I'm trying to explain this. You know that this is the same thing as exponential. If you open the bracket, ax plus ibx, true or false. Then in this function, we have what is called the real part and the imaginary part, true or false. The imaginary part is the I part, then the real part is the AX. So it means we can still transform this in this form. This implies that this is the same thing as exponential AX times, since it is plus, exponential minus BX. True or false? Because I want to do something here. True or false? So look at what I have just done. I want to break it down. I told you I want to break this thing down, since we have complex real roots. So look at the board very well. True or false? So if you agree with me, it implies that here we can transform the general solution in this form, y of g is equals to c1 exponential 2x plus 3ix, because by the time you open this bracket, then plus c2 exponential 2x minus 3ix. Amen? True or false? It's true, right? Okay. Yeah. So if you can see what I am saying, it means our y will now be c1 exponential. I want to break it down this way. 2x dot exponential 3ix, then plus c2, the same thing, c2 exponential 2x dot exponential minus 3ix. Amen? Are you seeing what I am saying? Look at the board very well. If you can see what I am saying, I don't think we are almost there. Okay, so if you can see what I am saying, you can now see that something is common among here. After breaking it down, I try to break it from here down here. Or we are using what? Indices. If you know your indices very well. Yeah. So can you see the way I'm breaking it down? Yeah. So it means this general solution could be written in this form, true or false, as a mathematician. But that is not where I'm going. I'm going to somewhere because of complex real roots. So I told you that we cannot just leave it like this as a mathematician. There's no sense in it. So I have to. So now look at this. Look at this general solution. At this point, something is common. What is common? Exponential 2x, true or false? Look at it very well. I want you to look at it very well. Look at it very well. Okay, yeah, look at it very well. Amen? Look at this. So we have to factor it out to be y equals to exponential 2x, open bracket, c1 exponential 3ix plus c2 times exponential minus 3. Oh, sorry. Exponential minus 3ix. Then close the brackets. True or false? Look at it. Look at it very well. True or false? So now, these are, like these ones, they are what? Hyperbolic functions. So we have to go back to what? Hyperbolic functions. It means we now write, note that exponential ax is equals to cos ax minus, plus exponential iax is equals to cos ax plus I sine ax. Then exponential minus iax is equals to cos ax minus I sine ax. Take note. So that is why I said, since they are complex real roots, it will not make sense if we leave it in this form. So with this, it means since we have exponential what? 3ix. So this will now be equals to cos 3x plus I sine 3x. Amen? Then, since we have exponential minus 3ix, so here will now be cos 3x minus I sine 3x. So this implies that instead of this is what we are going to write, and instead of this is what we are going to write. So you can now see that our general solution will now be, I'm going to write it here. Our general solution is now, it will become in this form. So our general solution will now be, this, factor it out, 2x open brackets. Our C1, let me write C1 very well. So can you see now, here is exponential 3ix. So as long as hyperbolic functions can sine exponential 3ix and hyperbolic, these are what? Complex. We can transform it in this form. It means instead of this is what we are going to write, cos 3x plus I sine 3x, then plus, it means this place cannot contain, so it's better I should clean the up. Let me clean the up. Mind you, I said I'm going to use two methods to solve this. So we are here to arrive, although we have arrived as long as we have obtained the general solution, but I said we have to transform it in this form. So it means our general solution now be equals to exponential 2x open bracket C1, since here is cos what? Cos 3x plus I sine 3x, then plus our C2 is here exponential minus 3ix. So instead of this, we are going to write times cos 3x minus I sine 3x. Yeah. So this is where you are going to stop. So now we are able to transform this to this form, and this is how it's supposed to be because of what? Complex real roots. So in case you come across questions like this and you arrive at complex real roots, this is not the final answer. I know you are not a mathematician, so you have to transform it. Take note of this. Any question, drop it in the comment section, please. Any question? Do you have any question? Yes or no? No question? Okay, so that is that. So it means that this is the numerical approach. Now I want to use D operator. Is that clear? I want to use the method of D operator. So I can clean everything here. D operator. You've been hearing of D operators to solve a second order differential equation. Amen. Two of us. Yeah. So now we want to use D operator to solve a second order differential equation. We have used the numerical approach. Yeah. So let me just introduce what D operator means. Is that clear? So let's look at it together. You know, D operator approach. D operator. Mind you, D represents D all over the X, and and take note, and d square represents, I'll break it down for you, represent d square all over the x square. Take note. So assuming we have a differential equation of this form, let's have it in this form. A d square y all over the x square plus b dy all over the x plus y equals to 0. Okay, cy equals to 0. It means if you are asked to use the operator, it's simple as ABC. Is that clear? It is not difficult. It's the same approach that will lead to what? Auxiliary equation. Is that clear? So it means anywhere you see this, you write D. Then you see this one, anywhere you see this, you write this. Is that clear? Do you agree with me? Are you following? Do you agree with me? Yes or no? So it means that here we are going to write it in this form: a d square plus b d plus c, open brackets, y equals to what? 0. I know you want to ask a question. Why y, open close the bracket, y is factored out? Can you see what I am saying? Look at the board very well. I will explain it for you to understand. Amen? Look at the board very well. Look at the board very well. Look at the board very well. If you can see what I am saying, I think look at the board very well. Yeah, let me explain why we have this second order differential equation. This represents d all over the x, and d square represents, this means d operator represents d square all over the x square. And after substitution, we factor out y. Why we have cy here, and y is being factored out. Look at it. Look at the board very well. Open your eyes and look at it. Look at the board. You know, some of you are blind mathematically, but I'm going to break it down. Open your eyes, both in the spirit and physical, this afternoon. Amen? Okay, if you can see what I am saying, the reason why the y is being factored out is, you know, here, look at it. We have y here, 2 of us. We also have y here, 2 of us. Then we have y here again. Because d operator represents d all over the x square. It did not say the y. Take notes. Very important. Is that clear? It did not say the y. It says what? D all over the x square. It means here y will be missing here. Also here y will be missing here. So by the time we place d, we will remove y, but y in it, that is, it means this is how this thing is. This is how this thing is. We'll still get back this thing. It means this is how it is. A d operator square y plus b d operator y then plus cy equals to what? 0. So if now we now replace it with this, he said d operator square is d square all over the x square, 2 of us. So it means this is the same thing as a d square y all over what? The x squared. Can you see now? Then plus BD is D, but mind you, there is y here, dy all over the x. Then plus our cy equals to what? 0. So you can now see that. You can now see that you are not confused. You are able to understand why y is factored out. Can you see now? So you can now see that we still get back the same differential equation, two of us. I love you guys. Please, I want you to like, share, and comment. I'll be very grateful. Is that clear? Okay, so let's go ahead to solve it. Can you see the reason why y is factored out? This is the reason. Any question? Amen? No question. So now, let us use the D operator with this explanation to solve this second order differential equation that we just solved. Is that clear? Okay. So, fast forward. So this is the equation, right? This is the equation. So, d square y all over the x square minus 4 dy all over the x plus 13y equals to 0. Two of us. They said use D operator. So with what I have explained so far, amen, it means here we are going to have what? D square y, then minus 4 dy, then plus what? 13y equals to what? 0. Two of us. Because they said use D operator. Can you see now? But the other one is let y equals to a exponential what? Nx. Two of us. So if you can see what I am saying, it means we have to factor out y. So that is why you always see minus d square 4 d square minus 4d plus 13 all in bracket what? Y equals to what? 0. Can you see now? So it means as it is, you are using what is called D operator to solve a second order differential equation. Do you agree with me? Any question? I love you guys. Please like and share. Do you have any question? So now, you now come back to this. Do you agree with me? As it is, y is being factored out. So we have to come back here to differentiate this. It means our dy all over the x. The other time, it gives us what? am exponential mx. And d square y all over the x square. It gives us am square exponential what? Mx. So instead of this, we have to substitute in this and this. So you can now see that at the end of the day, I told you, is the same thing. At the end of the day, you can now see that this is how it will be. It means here, we are going to have am square minus 4 and am square, sorry, okay, we are not going to put it this way. It means we are going to have d m square because y is outside, then minus what? 4m plus what? 13. So you can now see that your y is what? Your y is a exponential what? Mx equals to what? 0. Can you see now? Can you see now? So it's almost the same thing. So at the end of the day, you still use what? Any of the method, either factorization, completing the square, or formula method, anyone that is convenient for you because of time. you use it to solve. Then at the end of the day, you get back this same answer. This is the general solution. This is how to use the operator, because it's same procedure you will use. Because at the end of the day, if a exponential mx not equals to 0, it means this is your what? Your auxiliary equation. The auxiliary equation will now be this 13 equals to 0. So at the end of the day, this is what you are going to have. Your m1 will now be equals to 2 plus 3i, and m2, we have solved it before, equals to 2 minus 3i. And these are what? Complex roots. And complex roots, at the end of the day, the general solution, this is how it will be. Thank you for your time. Thank you for watching. Thank you for your patience. Please, pleading with you, I want you to like and share. Make sure subscribe to this channel and share it, recommend the channel. I'll be very grateful. Thank you for your time. I love you guys. Once again, thank you. I will do another video anytime, any day. Thank you. Be alert. Thank you very much. Please like and share, comments. I love you guys. Bye. I'm going to stop here. Yeah.